Hey, this is Tony from Adafruit, and in this video I'm going to look at Circuit Playground Express. So this is the fun new all-in-one electronics learning board, and how to use this with Windows 10. And I'll show a couple things. I'll show how you can program this using a system called MakeCode. That's a really cool visual editor. I've shown off how to use this, a really neat tool that Microsoft built. And then I'll also show CircuitPython, which is a version of MicroPython that you can use to program this board, so control some of the hardware from Python code. And again, I'll do this all using Windows 10. I actually picked up this little laptop right here. This is an inexpensive Acer laptop that runs Windows 10 because I wanted to kind of think about, okay, you know, if I was a kid in school today and I had something like maybe a Chromebook or an inexpensive Windows laptop, how could I go about controlling hardware like this? So in the last video, which I'll put a link to in the description below when it goes up on YouTube so you can check it out, I looked at Chromebooks and Chrome OS and how to program this board using CircuitPython from Chrome OS. And we looked at a couple Chrome OS apps that you can use. So I wanted to look at a Windows laptop now and check out what are some of the applications you can use and how to control this board from a Windows device, and maybe talk about, are there certain drivers and things that you might need to install. Now, most of this video is going to be Windows 10 because, again, that's the version of the laptop that I have. But I'll call out, there are a couple places where if you're running Windows 7 or 8, maybe even XP, although I'm not sure all the drivers and things work on XP these days. But older versions of Windows will work pretty much exactly the same, and I'll call out there's one tiny little difference, like one driver that you need to install with versions of Windows before 10, whereas in Windows 10 they've added in some extra drivers that make it easier to use boards like this, which is kind of cool. So we'll just kind of jump in here. Oh, and if you're curious, this laptop is the Acer 110. It was the cheapest Windows laptop I could find. It was $120, so it's actually a two-in-one. It's a tablet, so you can pull this thing apart. It is as low as you can get as far as spec-wise goes. It is 2 gigabytes of memory and 32 gigabytes of eMMC, which is like an SD card effectively to store the operating system. So this is a good test also to see, like, you don't need a high-end piece of hardware to control and run code on these boards. The cool thing is this little board is what runs your code. So, you know, you really just need a good text editor, a way to write code on your machine, and then you can copy it onto this board and start running it. So that's kind of the power too. And that if you have like 10-year-old laptop, it still will be great to do some of this programming and development and learn computing with it. So let's dive in. I will jump to a view of this machine. So you're looking at the laptop right here. This is just the screen output from it. And so we'll watch as I go with this. And again, like I said, it's running Windows 10. Also, a note, this is not running the Creators Update, which is like the very latest version of Windows 10. This is running a version right before that. So just an FYI, if you're curious what version I'm running, although I don't think the Creators Update has changed much, but I did read there was maybe some bug reports with some other MicroPython boards. So just FYI, if you're using Creators Update, I haven't used that one as much, but I'm going to update it after this video and try it out. Anyways, so let's just talk about, first of all, like I said, there are two interesting ways that you can program this board. One way is using this system called Microsoft MakeCode, and you can go to this from makecode.com. Again, I'll put links to all of these pages in the description when this goes up on YouTube. And I've actually done a whole video on MakeCode where I talk about what it does and how you can program boards. And it's pretty cool. You can see right off the bat, they've got some boards here like the Microbit, Circuit Playground Express, of course, and then some other boards on here. And the Circuit Playground Express, of course, is what I want to take a look at. And actually, I put together a quick little program right here. So with MakeCode, everything is programmed using a visual programming language. So it's like Scratch or Blockly, if you've seen some of those, where you basically have some control blocks here. You know, this lights up the neopixels on the board. You can drag these things around, and you can rearrange things. Like if I want to move, you know, maybe this up to the top or whatever, I can do that. So really cool and really nice in that you don't have to write any code. You're really just dragging around blocks. And this works pretty well even on this little low-spec laptop. This is all just served from a web page, so you don't need to install anything. You just visit this web page. And this is cool. I mean, I should preface this all by saying, like, I have not installed any driver or software on my machine yet for MakeCode. I've installed some other software, but none of that matters to MakeCode. So there's, I've installed nothing. I've just gone to this website. I've built a little program right here. I drag some blocks, and you can see there are different blocks to control things like animations, control flow, all of the basics of programming. And I won't get too deep into this because I've done a whole video on MakeCode. You can see on the left, this is a simulator that's showing kind of a simulation of what this code is going to do. So basically it lights up all of the pixels red, it'll pause for half a second, and then it'll light up all of the pixels blue and pause for half a second again. So you can see on the simulator, it's just flashing between red and blue. And it's kind of cool. I mean, if you want to change these colors, like if I wanted to, let's make everything, flash red and pink, for example, I can do that, or maybe we'll do like half of these as pink. Oops, I'm moving this around. This is one of the problems with these low-spec laptops. The trackpads are not the highest quality. I mean, you get what you pay for. Hey, 120 bucks. So sometimes if you rest your finger on the trackpad, it gets confused and thinks that you're dragging things around. But anyways, the way this works though is you click download after you have your sketch or your program built. And what it will do is it will actually compile your code effectively into a firmware file. It will give you this file, and it kind of tells you what to do. It tells you to press the reset button on the board and then upload this or copy this .uf2 file to the board. And I've shown this a few times, but I'll walk through here to show what you need to do. So first you need to plug your board into your laptop, obviously. So I will plug in my board right here. And the nice thing is, this board will show up as a USB storage device, so like a thumb drive, as if you connected a thumb drive with a bunch of files to your computer. But the neat thing is, it's not necessarily the program or like just random files that you're going to put on here. It's actually your program code that we're going to copy onto here, as if it's a USB drive. And again, I didn't have to install any driver or anything for this yet, so I just plugged in my board. And if I open up the Explorer, you can see there's a drive right now called CircuitPy. You might not see this if you get one of these boards from the shop right now. And by the way, I'll put a link to this board. Again, it's called Circuit Playground Express. And it's I mentioned this in the previous video too. It's kind of the all-in-one electronics learning board. Has things like some NeoPixels, buttons, sensors, and things built into it. But anyways, when you plug in your board, you may or may not see a drive. I happen to be running a CircuitPython sketch on my board, so I see a drive already. But what I'm going to do is on the board itself, which maybe I can show right here, you can see the board, one of these lights lit up. This is actually a little noise issue with CircuitPython that we're going to fix in the next release. But if I double press the reset button, then you can see it lights up. All the NeoPixels actually turn a light shade of green. And then this little pixel down here, this is the kind of the D13 LED. You can see it's kind of pulsing on and off red. So when it's pulsing like that, it basically means it's in the bootloader mode. And you might have noticed on my computer right here, there's this Cplay boot drive that just showed up. So now basically this board is waiting for me to copy firmware to it, because when you copy firmware to the USB drive, it's going to reprogram the chip using that firmware that you copied over. And the firmware we're going to copy over is what the MakeCode system actually just downloaded for us when I click that download button. So if I go to my downloads directory, you can see here's this Circuit Playground Untitled.uf2 file. And this is cool. This is all that I need to do to reprogram this board, is just literally drag and drop. Let's see, let me move this out of the way here just so I can use both my fingers here. So if I grab this file and if I copy it to Cplay boot, so it's programming it, and then check that out. So it's doing my animation here that I created. So you can see it goes red and then it goes half blue and half kind of pinkish, or I don't know what color that is. It's kind of like a whitish color, it looks like. But that's it. I didn't install anything. I didn't like have to mess with drivers or get some crazy software. I really just went to this webpage, MakeCode.com, and clicked on the Circuit Playground board, built a little visual program here, plugged in the Circuit Playground Express, double press the reset button and see the Cplay boot drive, and then just drag the UF2 file onto it and it programs it and you're ready to go with it. So that's really cool, and hopefully a great way for beginners to start experimenting with coding. Use a system like this with a graphical language. You're not restricted to only graphical stuff with MakeCode. There's also this JavaScript tab, which lets you program the board using a JavaScript language. It's actually TypeScript, which is a subset, and it gives you a little bit simpler version of JavaScript. Not simpler in capabilities, but simpler in syntax, because the syntax of JavaScript has gotten quite complex over the years. So sometimes it's better to take things out than add new features. So they've simplified things and made it easier to learn. But anyways, that's what MakeCode does. So great way to get started. And again, because there's no software that was installed, it's cool, and it should work with any Windows device, like even if you're in a school environment where the administrators have locked it down and you can't install software, you can't install drivers, as long as you can plug in a USB drive, you should be able to program and copy files onto that drive and start coding and controlling Circuit Playground Express, which is really cool. And this will also work with, there's a new version of Windows 10 called Windows 10S, and that's, from what I understand, going to be kind of a Chromebook-like version of Windows 10, where it will only let you run programs that are in the Microsoft Windows App Store. So I guess they have more control over the security of the apps and things if they restrict it to just the App Store apps. And so it sounds like probably in the future, a lot of these inexpensive Windows laptops will probably be running a version of Windows like Windows 10S. And so since there's no software to install, you're good to go though with MakeCode, and you can start controlling it from your Windows 10S device also. And early versions of Windows 2, 7, 8, XP, those all support USB drives, so you can program and use MakeCode from those just like this also. Okay, so the other thing I wanted to show is how to program this board with CircuitPython. So CircuitPython is a version of MicroPython that's a little Python interpreter that runs on these little embedded systems like the tiny microcontroller that's on this Circuit Playground Express board. I've done a bunch of videos on MicroPython and CircuitPython, so I'll run through on Windows and Windows 10 specifically, but I'll mention a few things about older versions. What's some of the software that you can use to program and use CircuitPython on your Circuit Playground Express board? And so we'll look at a few different pieces of software here and kind of go through the process of getting it running. So the first thing that you need to do is actually get the CircuitPython code running on your Circuit Playground Express board. Because the way CircuitPython works, you load the CircuitPython firmware onto the board, kind of like what you just saw with this MakeCode firmware. You load that firmware on, and then now the board is running a Python interpreter, and you can either copy Python source code onto the board that it will run, and it can control all the hardware on the board, or you can connect to what's called the REPL, the read, evaluate, print loop, which is like a Python prompt, and that's running on the chip on the board itself. So you can get an interactive Python terminal and just run Python code, like tell the board, hey, turn on the NeoPixel, or do some math operations, whatever. And so I'll show both of those things and how to do that from Windows here. But the first step, like I mentioned, is getting CircuitPython loaded onto the board. So to do that, you want to go to the CircuitPython GitHub repository and go to the Releases tab. And in the Releases tab, look for the latest release. It should be at the top here, so 0.10.1. And again, I'll put links in the description to things like this GitHub repository, so you can go to these easily when this is up on YouTube. And look at all of the files in the release. And so I've mentioned this a few times. For the Circuit Playground Express board, basically each file is a release for a different board. So you can see there's like the Arduino Zero release, there's Circuit Playground Express releases, some of the other Feather boards like the M0, the Huzzah, that's the ESP8266, the M0 boards like the Adalogger, the basic board, all kinds of releases here that you can grab. And so obviously we want to grab the Circuit Playground Express release, but you'll notice there are two of them. So there's a Circuit Playground Express.bin file, a binary file, and a Circuit Playground Express.uf2 file. And so for the way we're going to program this board, there are actually two ways to program it. We're going to program it using this .uf2 file, so the second file. This is the one that you want to download. So grab that .uf2 file. Oh wow, somehow I changed the zoom level there. That's kind of cute. Let me zoom that back in. So download that .uf2 file onto your computer. The .bin file, you have to use this utility called bossc, which is just stuff to install. You can do it, but you don't have to. So I'd say start with the UF2 files, but if for some reason UF2 doesn't work, the .bin files are another option. And the guide for Circuit Playground Express, or at least like the Metro M0 Express, they show how to use the bossc tool if you ever need to use that one to program the board. But okay, so as you notice, this is a .uf2 file that's just like the .uf2 extension that you saw from the MakeCode file. So programming it is exactly the same. I'm just going to double tap the reset button on the board. Oops, I didn't do it correctly that time. There we go. So it turns green. You can see the pixels turn green, and that little red LED is flashing, or it's not, it's flash, it's like pulsing on and off slowly. So that's telling me it's waiting for me to copy a UF2 file onto the board. So let's go back to the File Explorer. And you can see here's that UF2 that I downloaded right here. And if I grab that, and you can see there's a CPlay boot drive. So I'm just going to copy this over onto the drive, and it's copying it, and it's done. And you can actually see this pixel turns on. Again, like I mentioned, that's a little bug in Circuit Playground right now. Basically, there's a little bit of noise that can get into the NeoPixel signal line. So I think the next release, Scott has fixed that so that it'll turn off the pixels. But if you see something like that, again, CircuitPython, it's still in beta, so we're still fixing things and learning some of the little issues with the hardware with it. But anyways, the important thing is that I see after I flashed it with CircuitPython, I now have this CircuitPy drive. And you might not see the same files here. I was doing some coding on this earlier, and those files are saved onto the flash drive of the chip right here. So it's going to remember those files even if you load like a MakeCode sketch, because there's this little 2 megabyte flash drive that stores the Python code. But this is good. So it's running CircuitPython. So now the question is, how do I get my code running on this device? So I'll show a couple ways to do that. Maybe I'll start with a more advanced option, like a good option if you're getting into programming and you want to use like a more full-featured editor. And then I'll show another option that uses an app from the Windows 10 App Store. And so that's a good option if you're on a Windows 10 S device that can only run apps from the App Store. So we'll look at maybe two different workflows, like one where you're using just a normal desktop app that you've installed, and another one using an App Store app. So the desktop app that I would recommend, I mean, basically what you need in order to use CircuitPython, you need something to write code with, something that can write a .python.py file and save it onto a drive, because basically I need to save a .python.py file onto the USB drive for this board. So any text editor can do that. I like on Windows at least, and this actually runs on every platform, at least Windows, Mac, and Linux. There's this editor called Visual Studio Code. It's similar to the Visual Studio integrated development environment that Microsoft releases, which is this really nice big commercial package for creating Windows software. Visual Studio Code is a kind of a cut down or simplified version of it. It's actually like a full scratch rewrite of the editor. It's using a whole different technology underneath of it. But it's basically a code editor that Microsoft publishes that's open source, it's free, it's cross-platform, and it's actually pretty nice. I'm impressed. I've done a video on it previously also, so I figured, hey, since I'm using Windows, let's use the Microsoft editor for this. But even if I wasn't using Windows, this is a good editor. You can use any other code editor though, so like the Atom text editor, that's a really nice one from GitHub. Emacs, that's what Lady Ada likes to use. Vim VI, if you like that, you can do that. Notepad++, that's a nice little editor that a lot of people use. You can even use normal Notepad, but you do have to be careful because normal Notepad on Windows assumes the DOS style line endings where you don't have like a carriage return and a new line. I think you just have like a new line or something like that. And so if you open up a file that was edited on like a Mac, for example, in Notepad, all of your line endings will be messed up. It's really confusing. In general, I don't really recommend using Notepad just because it's there. It's it's like the tool of last resort. But spend the extra second to download a nicer editor. I would recommend. So Visual Studio Code, I've downloaded it. I've actually installed it already ahead of time. So that's what I'm going to use to write the code. But the other thing, like I mentioned, is you can connect to a terminal or a prompt, like a Python prompt on this board, and you can interactively run Python code. It's called a REPL, a read, evaluate, print loop. And you need a tool to access that from Windows because there's nothing built into Windows that lets you access that REPL on this board. This board, it's actually showing up as a serial device. So if I go to Device Manager in Windows, so if I run this, if you run Device Manager, this just shows you everything connected to your computer. And it's also good to double check. So after I've flashed the CircuitPython firmware, if I go into Device Manager, I now will see, if I kind of close a bunch of things here, there's a COM port, this USB serial device, COM3. And so that's basically this board acting like a serial device that I can connect to from a serial terminal program, and I can start sending commands to it and running Python code interactively. Now, on Windows 10, you'll see this and it will just work because Windows 10 actually ships the driver that you need to talk to that serial port from this board. It's a CDC, I believe, a USB CDC serial driver. Cool thing is, in Windows 10 it's built in and it should just work. You should just see a COM3 device, or if you have other serial devices, Windows will assign a different number to it, like COM4 or COM5. You might need to open up Device Manager like this to look through all the devices and find it. If you're on Windows 8 or 7 or XP, you will not see this, most likely. You'll probably open up Device Manager and there'll be a big exclamation point down here. Like, let's see, I think I had an example here somewhere. Yeah, under this human interface devices. Yeah, you see like this exclamation point on this device. Basically, that's Windows telling you that there's something connected, but it doesn't have a driver to talk to that. So if you see that, and this, to figure out which device it is, Windows is not very helpful, so it's a little hard. It doesn't kind of tell you like what the name of that device is, unfortunately. But if you see a device with a big exclamation point there, and you don't see a COM port for your Circuit Playground board, you probably have to install a driver to make this work. But luckily, it's pretty easy. So I'll put a link to this page. This is a Windows driver installer that we made from Adafruit here that just packaged together all of the drivers that you need for all of our boards. So for this, go to the Releases tab, grab the latest Adafruit drivers.exe file, run that, and it will run a little installer. It's going to ask you which board you want to install the drivers for. It can't hurt to just select them all. I think they're all selected by default, but at the very minimum, select the Circuit Playground Express board, and that will install the driver that you need to see that serial port in Windows Device Manager like this. So, make sure you get that driver installed. And again, on Windows 10, you don't have to do that, which is kind of cool. The driver's already installed. Okay, so once you have the driver installed, and we've got the code editor, like I mentioned, Visual Studio Code, now I need a piece of software to actually open that serial terminal and talk to the Python prompt. And again, there's a lot of different software that you can use in Windows to do this. But I like a piece of software right here called Putty, P-U-T-T-Y. And it's basically just a very simple terminal program meant to connect to remote servers, like if you're using the SSH or the Telnet protocol, but it also has serial protocol built into it. So it's a very simple little terminal to connect to a serial device. And I like it because it's free, it's open source, it's just one exe file. Like you don't have to install all this crazy stuff. So you can use the installers they have right here, and that installs. They have a bunch of other tools that are mostly used with like SSH, like you can copy files securely, but it's really just the putty.exe. Like if you don't want to use that installer, you just need this putty.exe right here, the SSH and Telnet client. So grab that, and in your downloads, then you'll actually see the putty.exe. So if I run this, I'll start with showing you how to access that serial terminal, basically the Python prompt on the board. So you run this, you get this kind of confusing UI, at least if you're a beginner. This is maybe a little bit scary. There's a ton of options here, but don't worry, it's actually really simple what we need to do. What I need to do is go to the serial mode. So there's the different connection types, and I want to switch it over to serial right here. And then I have to pick the COM port. And again, this is another confusing thing that Windows kind of does. Like there's no nice little drop-down list like that would list all of the COM ports. It kind of assumes that you know what you're doing. But if you're not sure, like I said, open up Device Manager. So just press the Start button and type device space manager, and that'll start searching for it. This is what you want to run. And then again, look at this ports part of the Device Manager, and you should see a device here, and then that COM name is what you want. So COM3 is the name of this board. So if I go back to Putty, then I can say, okay, instead of COM1, I want COM3. And then you do need to change the speed. So by default, 9600 baud, that's too slow. It's actually 115200, 115200 baud. And that's the baud rate that you need to use when connecting to a CircuitPython or a MicroPython board. And at this point, you're pretty much ready to go. So you can just click this open, and it's going to connect to the board. I'm actually going to load up these settings here that I created ahead of time. You can save these settings, which is kind of nice. Just because I went in and I tweaked the font size so it's a little bit bigger so that you can read it a little bit more easily. But again, you don't have to do that. So I'm just going to click open. And this is connected to the board. So this is kind of cool. You actually see some text. It's printing out hey, I'm in this auto reload mode. You know, you just save your files to the board, or you can press enter to use the REPL, and I'll do that. And so I've shown this in a bunch of videos, but this is the Python prompt. So this is a Python interpreter running live on this little microcontroller, and I've connected to it over that serial connection. And so that putty terminal program is where I can type in some Python code here. So like print hello world, and that just executed that Python code on this board. So that's really cool. And that's kind of one part of using the CircuitPython and MicroPython is, you know, using this REPL and just interactively controlling the hardware and the files on the board. So let's drag this over, and we'll keep this on this half of the screen. This is a cool thing. I think Windows 10 added this. Maybe it was Windows 8, but you can, you know, basically drag a window onto one side of the screen and get it to take up that side. Now let's run that Visual Studio Code editor. So I've actually got it under my recent programs here. And this is, again, a text editor. It's a really nice little programming text editor. And I've actually already, ahead of time, I dragged it onto this side of the screen. So this is kind of nice in that now the left half of my screen is my code editor, and the right half is the REPL, or the Python prompt. So it's a really good workflow I found for doing some of this Python development, where you're going to save your file on the left side. We're going to save this as a file on my Python board, and then I'll be able to see the output when it runs it on the terminal right here on the right hand side. So okay, to get started with Visual Studio Code, I'm going to create a new file, and let's save this file just right off the bat. I'm going to save this onto my CircuitPython board, so that you can see this is the drive that it's selected, that it shows up as a D drive. It just happens to look like, but look for that CircuitPy name. And I'm going to save this as a main.py file. Let me just select all this. Come on, Windows. I guess my double tap is not working super well. So all right, let's do main.py. And then let's see if this gives me an option. Okay, yes, I'm going to make sure that I tell it I want it to save this as a Python file. So this is going to save it as main.py. There's actually already a main.py there, but we're going to overwrite it. We're going to write our own main.py. So I'm going to save this. It's asking me, do I want to replace it? Yeah, let's replace it. So, okay, so I just replaced the main.py. And again, that's saving this main.py onto this board, onto the drive that it shows up as. And the cool thing with CircuitPython and MicroPython, when you save a file called main.py onto the board's file system, it will treat that as kind of the main code that it runs whenever the board boots up. So I can put some code inside of here, like let's say print hello world. And it's gonna, when I save this, it will actually be able to run this main.py file. So I'm gonna save it. I just pressed Control S on my laptop, or you can, you know, go into the file save options up here if you want. And it's saved onto the board. Now on the right, this is the output of the board from that REPL. Now the one thing to know is when you start using the REPL, like I pressed enter and, you know, I typed in some Python code like this, you know, 5 + 1, whatever, it won't auto reload my main.py file. Because since I'm using the REPL, we don't want to like just blow away anything I've done in the REPL, you know, even though I've saved the file there. So I need to tell my board, hey, I'm done using the REPL, and I want you to go back and rerun your main.py. So the way you do that from inside of this REPL window, you want to press Control D. D as in dog. So Control D on your keyboard. That will reboot your board, and it'll put it back into this auto reload mode, and it will run your main.py. So let's see what happens. I'm going to press Control D. So I just did that, and this is cool. So you can see it says soft reboot. So that's what the Control D command tells it to do. And then it boots up and it says, okay, hey, your auto reload is on, so save your files over the USB drive, just like we did on the left-hand side here. And then it's kind of cool too, it also shows me the output. So here's main.py output, hello world. So this is actually showing me the output of this main.py script that I just wrote on the left-hand side here. And then it's telling me if I want to go back to the REPL, I can actually press enter and start typing some code. But let's keep it in this mode, so this auto reload mode. And let's just see that it works. So if I add an extra line like, you know, Windows 10 is cool. We'll add something like that. And then I'm going to press Control S to save the file. So just save the file. And this is cool. Notice on the right-hand side, it noticed that the file changed. It did a reboot of the board automatically. I didn't have to press anything. I didn't press Control D or anything like that. I just saved the file on the left-hand side here in my code editor. And then here's the output from it. So it says, you know, hello world, Windows 10 is cool. So that's pretty neat. I mean, this is a really nice little Python workflow in that I can write my code on the left-hand side here, and then I can see the results on the right-hand side here. So like, let's say print, 1 plus 1, or 1 plus 2 is, and then let's put in the output of that. Let's do 1 plus 2, like that. So if I save this, then we should hopefully see, hey, it just rebooted, and then there's 1 plus 2 is 3. So really cool way to run Python code. And again, it's Python running on this microcontroller. It's not running on my computer. Notice I never installed Python. This computer doesn't have Python installed on it at all. So it's really neat, and then you're using Python on this little board. The only software that I installed is that Visual Studio Code Editor and that PuTTY terminal, serial terminal program here. So that's really cool. Kind of a neat little demo of what you can do with this. So let's look at another option though. So Visual Studio Code is pretty nice, and this PuTTY terminal is also pretty nice. I guess I'll keep PuTTY open for now. Device Manager, I don't need this anymore. So I wanted to look at, are there options that let you program and write code using an app from the Windows 10 App Store? Because like I mentioned, there are those devices, the Windows 10S version of the operating system, where you can only install programs from the App Store. So I wanted to see, are there code editors in the App Store? So if you open up, this is the Windows App Store, you can actually see there are some code editors in there. Actually, I'll go to the home page here so you can kind of see. It's just like any other App Store. It's got games and all kinds of stuff in there. Unfortunately, it's not as full-featured as like the Android App Store, for example. So I have a little bit harder time finding editors and things and software inside of here. But I did find there is something called CodeWriter. This is an app that I found, and I tried a bunch of apps, and this to me seemed like the best one. But you might try and look around and see if there's some other apps. But check out this CodeWriter app, and I'll put a link to this in the video description when this goes up on YouTube. You can install this app, and I've actually already installed it ahead of time. And this is a basic little code editor. Now, unfortunately, you might be wondering, what about Visual Studio Code? It's not in the App Store yet, unfortunately. So hopefully in the future they'll get it in the App Store, and maybe you could find Visual Studio Code right here from the App Store, which would be really cool, because then those Windows 10S devices have a really nice editor. But for now, I think CodeWriter is probably what you want to use. So that's a really good code editor. The other question might be, well, what about a serial terminal? Because unfortunately, PuTTY is not in the App Store. So if you search for PuTTY, you're not going to see anything in here, unfortunately. You see a whole bunch of things like, you see some commercial programs. So the other thing is, I only wanted to use apps that are free, because I don't want to tell people like, oh, go install this $5 app just to use this basic hardware. So I'm only looking for free apps. There are some paid apps. I have not used these. I have no idea if these work. Maybe they work. I don't know. Let's see. Does MetroPuTTY, does it mention? Because you're looking for something that supports serial access. So I don't see it even mentioning it here. So who knows if this supports it? I guess there's a free trial. You could try it maybe. You can search for serial in the App Store. Unfortunately, I really couldn't find a serial terminal app in the Windows 10 App Store. You can kind of see that this is another annoying thing about the Windows 10 App Store. It's showing me games and things when I really just want to look at apps. You can even see movies. I don't really care about these movies, but here are the apps. So if I look at these apps, I tried a bunch of these apps, at least the free ones, like I mentioned, and I couldn't find one that worked. The Serial Debug Assistant was the closest to working, but it says it connects to the board, but I'm not able to actually send and receive any data. So right now, I don't think the Windows 10 App Store has enough stuff in it to at least let you do the serial REPL kind of style of seeing the output of your board through that REPL. It looks like you're gonna have to use like this PuTTY tool that I mentioned here. So unfortunately, again, hopefully in the future, check the App Store and see if maybe some new stuff has been added. And if eventually when an app comes along that hopefully fills this gap, I could maybe do a follow-up video that kind of shows like, here's the Windows 10S style of using CircuitPython. But for now, the best you can do is getting that code editor. But I'll show you how to use that editor real quick. It's not a bad editor, so it's called CodeWriter, and I'll run this editor. And this editor, let's see, we'll dock it to the side like we did before with the Visual Studio Editor. Now this code editor, it was written as a Windows 8 app, which means it can still run in Windows 10, but the user interface is a little different. In Windows 8, if I remember correctly, all of the applications ran full screen. You couldn't have this app as a window like this, whereas in Windows 10, they let you take those old Metro style apps. Well, it actually wasn't called Metro, it was like the modern style interface or whatever, but they let you take those apps and run them in little windows like this. But the unfortunate thing is if a program was written for Windows 8, it kind of feels weird in a window like this, because in Windows 8, it had this thing called the charms bar, which I think is still here in Windows 10. I think if I drag in from the side, yeah, this thing is, well, I guess it's the action center now. I don't even think it's the charms bar, but oh boy, now I don't know what I'm doing here. So anyways, you had to like drag in from the right-hand side to get to the settings of your program. But in Windows 10, I think, and I don't know, there's probably a better way to do this. People that are more familiar might be able to say in the comments. But if you open up this app commands, then you can actually see it pops up this bar at the bottom, and then you can click this settings bar, and this is where you can go in and actually like change some of the settings for this editor, like the font sizes and things like that. So just an FYI, you know, when you load up this editor, you might be wondering like, boy, how do I use this thing? And don't worry, you know, you're not crazy. It's just the UI hasn't really been moved over to work with Windows 10 yet. But anyways, it's simple enough. I mean, basically I want to create a Python script, so I click the Python button. And again, the big thing is I need to save this as a main.py on this board. So if I I'll put in some Python code, we'll say print hello from code writer. And then to save this, you have to do that little song and dance that I just showed, unfortunately. So I'm just curious, let's see if this brings up, okay, so it looks like you can click this little ... down here, and this brings up this kind of more extended menu. The other way I saw to get into this is you go to this app commands, and this will also bring up the menu here too. So there are two ways to do it, it looks like. And then click this save button right here, and then I want to save as, and then you get that kind of familiar save as dialog. And so yeah, let's save this on my CircuitPython board, and let's save this as a main.py file. So it's already got that there. I'm just going to save this as, it knows the file extension is .py. So let's save that. It sees the file's already there, so yep, I want to replace that. And so I do that, and you can see it said main.py saved. And then notice on my right-hand side in the PuTTY terminal, it just ran that code. So hello from code writer. So pretty cool. You know, I'm good to go, and I've got my code editor right here. And this is, again, another way to edit files. It's just unfortunate that, you know, hopefully in the future there will be a Windows 10 App Store app that gives you this serial terminal, kind of like PuTTY. Maybe even PuTTY. If someone could put PuTTY into the App Store, that would be really nice. And then on Windows 10s, you could get this kind of workflow going. But unfortunately on Windows 10s, you know, you would just have your code editor, and you wouldn't be able to use PuTTY and get that output. Which is still okay, because the cool thing is with a board like Circuit Playground, you can still see some of the output, like I have the NeoPixels on here. So let's recreate that MakeCode sketch. You know, we'll just blink all the LEDs, like red and blue colors, for example, and we should be able to see that as output on my board. So even without that code editor, let's see how to do that. So in order to use the NeoPixels, I need to load a module onto this board. So there is a module, this NeoPixel module, just because basically this board with CircuitPython, it's still kind of in beta. We don't have everything shipped with it out of the box. So NeoPixels, you need to install a module to control the NeoPixels. So go to this GitHub repository. I'll put a link in the description when this goes on YouTube so you can find this repository. Go to the Releases tab, and then in the release, you should see this neopixel.mpy file. Download that file onto your computer, and then in your downloads folder, you'll see that there's that neopixels.mpy. And then the cool thing is, just drag it onto your CircuitPy board right here. I've done that ahead of time, so you can already I already have that neopixel.mpy on this board. But you know, to load a module onto the board, it's as easy as just dragging the .mpy file onto it and just tell it to replace it. And let's see, what did it do? Oh, interesting. Huh, I haven't seen that error before, so I don't know, let's try this again. It might be because I already have the file on the board, so who knows. Sometimes, again, hey, CircuitPython, it's in beta here, but you ultimately want to get this neopixel.mpy onto the board, so I had already copied it ahead of time, and I think that's why it's getting confused here. Anyways, the file is on the board, so now I can use this module, And I've actually done, I think there's a whole guide on using NeoPixels and things, so I won't get into the details of the usage here, but I'll show you a quick little demo. So here's maybe how I can blink all the NeoPixels using the CircuitPython code. So I'm going to delete this code from my main.py, and let's just see if I can increase the font size real fast. So let's just go into settings, just because I know it can be kind of hard to read some of these things. Yeah, let's bump up the font size to like 20. Let's see if that changes things. Okay, I think that's a little bit bigger. Okay, so to use NeoPixels, I need to import a few modules. I need to import the board module. I also need to import that NeoPixel module. That's importing the .mpy file that I just copied over a moment ago. And then I also am going to import the time module. That's built into Python, MicroPython, CircuitPython. That gives me a delay function because I'm going to turn on the NeoPixels, delay for 500 milliseconds, and then change the NeoPixel colors, and then delay for 500 milliseconds, just like you saw in that MakeCode sketch. I'm going to rewrite this MakeCode sketch just in Python code. So, light up the pixels, wait 500 milliseconds, light up the pixels, and then wait 500 milliseconds again, and just loop forever doing that. So the way to write that code, first I need to initialize the NeoPixels. So I'm going to create a NeoPixel object, and that's in the NeoPixel module. There's a NeoPixel class, and I need to tell it what's the pin that's connected to the input signal for the NeoPixels. So for the Circuit Playground Express board, it's actually a pin that's internal to the board. So you reference that with this board.neopixel object here. And then I need to tell it how many NeoPixels are on the board. There are 10 NeoPixels, so I'll put that as the second parameter. And then at this point, I'll just do an infinite loop while true. So this is just going to run my Python code forever. And then let's do pixels.fill. So the fill command will actually set all of the pixels to a specified color. And you specify the color with a 3 tuple. So tuple in Python, you put parentheses, and then you can put any number of comma-separated values. And so there are 3 values. These are numbers that go from 0 to 255. And it's the red color value, the green color value, and the blue color value of all the pixels. So let's set them red. So 255, 0, 0. That's going to be the red color for all the pixels. Now, this won't actually change the pixel color because the fill command just changes the memory of what the pixel color should be, because you can run you can like change the color of a lot of different pixels all at once, or maybe with a bunch of different commands. And then you want to call the pixels.write command, and that will take whatever changes you made to the pixels before that write command, and it will push them out to the NeoPixels. It'll actually, then you'll see the NeoPixels change their color. So you won't actually see the NeoPixels change color until this write command is called. And then let's call time.sleep. This is the delay function in CircuitPython and MicroPython. And this takes the sleep time in the number of seconds. So it's not milliseconds, it's seconds. So 0.5, if I want to sleep for half a second, I can use a floating point value like that, which is kind of cool. And then let's change all the colors of the pixels again. Let's do fill, and this time we'll do blue. So the blue value is 255 and everything else is 0. And then pixels.write, because again, I need to tell the pixels to update their colors. And then time.sleep for half a second here. And if I did everything right, if I save this file, hopefully we'll see things start changing on our board. So I did that, and okay, I think I got something wrong, unfortunately, because nothing's happening on this board. So there obviously must be an error. And unfortunately, without access to the serial terminal, this is where things get a little difficult. So I'm going to open up that PuTTY terminal, and oh, interesting. Wow. So I did something kind of wrong, or my board got really confused. It's saying value error invalid.mpy file. So something was wrong. You saw as I tried to copy that .mpy file onto my board, it gave me that error that it couldn't copy it. So let's just delete it from my board. This is in the file manager. I'm just going to delete that neopixel.mpy. So yes, I do want to permanently delete that. And now let's go back, and let's go back to my downloads, and let's recopy this over just to see if that hopefully fixes the problem. So I did that. And now let's see. All right, I don't see anything happening here. So okay, so it looks like it rebooted, and now it's confused about, it says invalid syntax on line 1. So this is a little interesting. So I'm importing the board module. This is line 1 of my code. So I'm not sure why it's mad about that, but let's restart my board. So I'm going to press that Control D, D as in dog. Let's see what happens here. when I do that in my serial terminal. Oh boy, the board might be in a really weird state. Oh, okay, wait. All right, here we go. Sorry, I just pressed enter. Let's press Control D. So I just want to see what's happening. Okay, wow. So it is really mad about this. So let's just resave this file. I wonder if there's something wrong. Maybe there's like some white space that I accidentally got on this file. So let's just save this as, yeah, there's my main.py. So let's save this file. And I just saved it. And okay, so that's good. So I don't see the error. But this is interesting. I don't see the NeoPixels lighting up on this board. So wow, this is a total demo fail right here. So it's hopefully running the code. Actually, here let's just, to make sure that it's running the code, let's type print hello world at the top here. So let's save that. And I just pressed Control S, and it did not save it because I don't see anything. Wow, I guess there's no Control S shortcut in this editor, so I guess I have to go in and manually tell it to save right here. So we'll click the save button there, and then let's see what happens here. Oh boy, wow, it looks like it did not save the file. I don't know if this is something wrong with the editor or something wrong with the board. Let's see. I definitely have a CircuitPy drive right here, so I'm not yet going to blame CircuitPython. I'm going to blame this editor. So maybe this is not the best code editor in the world. Let's close the editor and reopen it real fast just to see if we can get this to work, because I want to see these pixels blinking and hopefully get this demo to work. But you know, again, like I mentioned, the Visual Studio Code editor seems to be a little bit nicer editor that you might want to use, but I wanted to see if I could do something from the App Store. So okay. So let's see if I can actually open that file. Let's see, is there, that's the save command. Which one would be the open command? Close all, no, that's probably not it. Let's see, what if I create a new tab? I don't want to open a new file. I think in this editor you go to the right. Yeah, here we go. So if I browse, okay, here's the main.py. So if I click that, hopefully, fingers crossed, it will open my main.py. But boy, this editor might be having some problems. This might not be the best editor. Maybe this is a good demo of what code editor not to use, unfortunately. Oh boy, this thing is really not having any luck with this file. So, okay, well, let's just, I'm gonna unplug my board. Let's put everything back into a good state. So, okay, yeah, Putty's all mad that I pulled out the board. Let's plug the board back in. And let's see, let's try this one more time if I can get that code editor to edit that code. So let's open up CodeWriter again, and we'll put it on the right side, and then let's open up that file. So if I go here, and if I open this, and maybe before I do this, I just want to make sure that I see the drive. Oh, I don't even see my board as the drive down here. So wow, I might have gotten Windows into a really confused state now. So let's reload the board here, and maybe this might be demo fail. I might throw in the towel on this demo and say that this is not a good demo. Wow, boy, the drive is not showing up at all now. So I think I might need to reload CircuitPython onto this board. So I have a feeling I've probably gotten my board into some kind of a bad state. So rather than try to charge through this demo, which is probably going to have issues, maybe stick with Visual Studio Code like I showed in the first part of the video, and the Putty editor. It looks like those are a little more full-featured. And again, unfortunately, on Windows 10 S and App Store only devices, you can get a CodeWriter, which sort of seems to work, but you can't get that REPL Putty tool anyways. So, you know, it doesn't look like an App Store only workflow is going to work anyways. So, you know, the way to go right now is using an editor like Visual Studio Code, and then using that Putty tool to edit your files on the board. So, and like I showed before, you can get kind of a cool workflow where you've got your Python code on the left and you've got your terminal on the right-hand side. Okay, so I'm going to wrap up this video then. It's starting to go a little bit long. So if folks have questions, maybe throw them into the chat, and we'll jump back to the main view right here. So again, like I mentioned, this was a demo of Circuit Playground Express, which is kind of our all-in-one electronics learning board. It has NeoPixels, sensors, everything built into the board. And I showed two ways to use it with Windows 10, and really any version of Windows. One way is using MakeCode. This is a really cool system from Microsoft where you can use a visual programming language to write code and then copy it onto your board. or you can use CircuitPython, which is a version of MicroPython, to run Python code directly on this board. And I showed a workflow using the Visual Studio Code editor where you can edit your code and save it directly on the board, and the board will run your code automatically. And then you can see the output of your code using a serial terminal application like the PuTTY terminal application. And links will be in the description below on YouTube, so you can go click down to those to see all of those tools and things that I've used in this video. We showed how to run code on this board using that. Then I looked at, I had a major demo fail, unfortunately, but I was hoping to be able to show an app from the Windows 10 App Store that you could use to edit code, an app called CodeWriter. But unfortunately, it looks like it didn't work super well, at least in this demo. It did work before I tried to demo it, so it sort of works. But like I said, there's no serial app, unfortunately, in the Windows 10 App Store, so I don't think Windows 10 App Store and Windows 10 S is ready for using something like the CircuitPython programming. But you can still use MakeCode on that platform. It still works great there, so stick with that. Otherwise, if you're using Windows 10 S, the only way you're using it right now is if you have one of the fancy new Surface laptops, from what I understand, and all of those get a free upgrade to Windows 10, I think Home or Pro, or one of the full feature version of Windows. And I would highly recommend you take that upgrade while you still can, just because then you can run a tool like Visual Studio Code that I was showing on your device. So give that a shot. I don't see any questions, so I'll wrap up the stream. So thanks a lot for watching. This is Tony from Adafruit. Check out youtube.com/Adafruit. You can see this video, all kinds of other fun project videos, and check out twitch.tv/Adafruit. You can see me stream these things live. I like to do a live stream usually every Friday. And I've been looking at Circuit Playground Express and CircuitPython. And like I said, the last video I showed on a Chrome OS device, a Chromebook, how to program CircuitPython. This video I showed with Windows 10 and other versions of Windows, how to program CircuitPython and MakeCode. And in the next video, maybe I'll look at another platform. I guess Macintosh is probably one of the only ones left. I'm actually curious though. Let's see if we could do something like Android, like an Android phone. That would be neat to write code from an Android device, because like you saw, any device that can talk to a USB storage device, anything you can plug a USB file stick into and access those files, and more importantly, if there's a code editor on that device that you can save a file onto that drive, you can run Python code on these boards with that. So I think Android will work. I've tried it a little bit. I've seen it work a few times, but maybe tune in next week and we'll see if I can figure out a workflow from Android to make this work. I did also try, if anyone's curious, I picked up one of these. This is the Kindle Fire 7. This is like the cheapest tablet you can get. This is a $50 7-inch tablet. Not a bad device, especially for $50. Unfortunately, it does not support the USB file storage right now, at least in its stock form. Apparently, if you root it and install a new kernel, it can support that, but I'm not going to recommend everyone does that. So unfortunately, no luck with those yet, but hopefully in the future, maybe Amazon will add support for that and we'll be able to program from your $50 tablet, one of these little boards. So that'd be really cool. Anyways, thanks a lot for watching. This is Tony from Adafruit. Click the like or the comment, the subscribe button. Let us know that this is cool content, and we'll keep making content like it in the future. So until next time, it's Tony from Adafruit. Thanks for watching. I'll see you later. Bye.